Sodium chloride, also known as salt, is a compound of the atoms sodium and chlorine. Let's take a closer look at the atoms. Sodium has 11 protons, 11 electrons, and 12 neutrons. The protons and neutrons in an atom are in the middle of the atom, which is called the nucleus. Electrons orbit around the outside of the nucleus in energy shells. The first energy shell has up to 2 electrons, and the other shells have up to 8 electrons. Sodium has 11 electrons, so the electron configuration is 2, 8, and 1. The outer shell, which has 1 electron, is called the valence shell. The mass of an atom is in the nucleus. There is just empty space between the electrons. The electron configuration is 287. The third shell of this atom, which can hold up to 8 electrons, is not full. To become stable, chlorine needs to gain just 1 electron, filling its outer shell. To achieve stability, atoms need to have a full outer shell. Sodium needs to lose just 1 electron to do so, while chlorine needs to gain 1. Since chlorine needs to gain an electron, an easy solution is to take the electron that sodium loses. During this exchange of electrons, each atom can achieve stability. Though sodium has lost one of its electrons, the amount of protons it has remains the same, meaning that there is now one more positive proton than negative electrons. The final ion will have a positive charge because of the difference in numbers of protons and electrons. Chlorine works in the opposite way, ending up with one more electron than proton. Since it has gained a negative electron, the overall charge becomes negative. When two ions form an ionic compound, their negative and positive charges need to add to zero, which determines the ratio of one ion to the other in the compound. Sodium's positive charge of 1 can balance out chloride's negative charge of 1, which means the ratio is simply just 1 to 1. Sodium chloride is what table salt is made up of. We use it in many things. Fish and chips, for example, are dusted in sodium chloride to add to the taste and make them more palatable.